In our previous video, we were able to discuss what brings about acidity and basicity. Measuring acidity and basicity of a solution can be done by measuring the concentration of hydrogen ion or hydroxyl ion. But sometimes this can be so complex. Let's say we are having something like 2.5 times 10 raised to power minus 5. Things like this. This is a lot of number. If we can represent this in a simpler way, then it's better and it's easier to understand. So that brought about the concept of pH. pH is the negative logarithm of hydrogen ion concentration. And apart from pH, we also have pOH, which is the negative logarithm of hydroxyl ion. Just like in the case of ion products, the ion product of an aqueous solution is always 1.0 times 10 raised to power minus 14. So 1.0 times 10 raised to power minus 14 molar square. So for that same reason, when you add pH and pOH together, it will always give you 14. So pH plus pOH is equal to 14. And the value of pH could range from 0 to 14. Likewise that of pOH as well. So if it is on 0, it means it is very acidic. And if it is on 7, that is neutral. On 14, very basic. And in between, the acidity increases along this part, while the basicity increases along this part. So here I put fairly basic, here very basic. Let me make it clear that there is no gap where you can say, okay, from this point, then this is very basic, this is fairly basic. This is just telling you that when it is closer to the neutral, it is fairly basic compared to the one that is closer to 14 or 14 itself. This is also telling you that from this 0, any number that is closer to 7 is fairly acidic compared to the one closer to 0. For example, 5 is less acidic compared to 4, and 4 is more acidic compared to 5. So apart from simplicity, this number also gives us a sense of scale. For example, when you have a pure water, the pH is 7 and the hydrogen ion concentration is 1 times 10 raised to power minus 7. So when you have another solution that have its hydrogen ion concentration to be 1 times 10 raised to power minus 6, the meaning is that if you find the pH of this is going to be 6. Let's say you have another one that is 1 times 10 raised to power minus 5 and the pH is 5. Now look at this number and this number. If you multiply this number by 10, what you have is this. And if you multiply this also by 10, you have this. So for every one jump on this scale, the acidity, or let me say the concentration of the hydrogen ion is going to multiply by 10. So the hydrogen ion in a solution with pH of 6 is 10 times greater than that of 7, and 7 is greater than that of 8 by 10 times, 8 is greater than that of 9 by 10 times, and so on. So as we have this for hydrogen ion, it also affects the concentration of the hydroxyl ion, because when you multiply hydrogen ion and hydroxyl ion concentration together, it should give you 1 times 10 raised to power minus 14 molar square. So if the concentration of hydrogen ion is increasing, that of hydroxyl ion will have to decrease. And that is the reason why when pH of something increases, the pOH will decrease. So practice this question, they will help you a lot. Thanks for watching.